4e solving quadratic equations by factoring. So we've been factoring, but now we're going to have, instead of just expressions, we're going to have equations. We need to talk about the zero product property, what we have to make sure we do before we actually start solving it. We're still going to be needing to look for greatest common factors and see what they do. And wonder if there's always going to be two answers. I'm not always big about talking about all the properties, but I do want to talk about the zero product property because it gives us a good opportunity to talk about some vocab that we need to make sure we all agree on. So product is the result of multiplication. So this would be, factor times factor equals 0. So I've been saying we've been making factor pairs when we make our t-charts. So if we're talking about zero product property, what we're saying is if I want to end up with 0 and I've got two things being multiplied, one of those two things has to be 0. The first thing can be 0, the second thing can be 0, the 10th thing can be 0. If I've got a bunch of things being multiplied, one of the items has to be 0 if I'm ending up at 0. So when we're solving things that look like this, and I'm just going to give you one that's already factored. 8x minus 1 and x plus 5. So let's just pretend that one that's already been factored. Our equations we're going to have in standard form, and then we're going to factor them, and we're going to look like this after we factored them. So I want this talked about next to the zero product property, because what we're saying is either this thing is 0 or this thing is 0. One or the other has to be 0 if we're going to end up at a product of 0. The two factors, one of the factors has to end up at 0 for the product to be 0. So what we're going to do is each time we have this, we're just going to set up two little baby equations and say either this one's 0 or this one's 0. This one's super simple, and so I don't expect you'll hardly ever show that step. This one we have to do a couple steps, and we're going to have fraction answers. That's okay. So my two answers, move over here, my two answers would be x equals 1/8 and x equals 5, negative 5. So those are the two answers. And what we're saying by that is we're saying I'm going to take these two things and multiply and end up at 0. 8 times something minus 1 and something plus 5. And I could stick a negative 5 in there, in which case this will be 0. And I don't really care what this other thing is. It happens to be negative 40 minus 1. It happens to be negative 41. But the big deal is 0 times anything, we end up at 0 equals 0. I could do the same thing with the other one. 8 times something minus 1 times x plus something. Oh, not x plus something, something plus 5. And I could likewise plug in positive 1/8. So here I'm going to have that cancels, that cancels. I have 0 times, I'm not even going to worry, I'm going to write it as a mixed number. I couldn't do the math like that, but I know 5/8 times 0, it's 0. So either of those factors can be 0. Doesn't matter that they don't both turn into 0 at the same time. They don't both have to be 0 at the same time. So we just solve each of the little baby equations. This is our answer. The rest of it was just me showing you why it works. I'm going to show you another kind of smallish equation, and I'm going to do some of it kind of fast because we spent a whole lot of time factoring this week. So that's not equal to 0. We said when we're doing these kinds of things, we've got to get them equal to 0. So our first step is always going to be to get them into standard form. So again, that's my problem. I don't want to mess with that. If these are my notes, I want to know that's what I started with. So I'm going to rewrite it before I start messing with it. So I need to get it equal to 0. So I'm going to subtract 2x from both sides. Now it's in standard form. Remember, it has to be in descending order. And now we can start factoring. I'm going to use A and B and C. I've got things that are going to multiply and give me -8 and add it to -2. And that's going to be this choice. I'm going to go through all my steps to factor. First term, first box, last box, term, last box. Bring my terms over from my list of factor pairs. Factor out my greatest common factor of these two, and these two, and these two, and these two. So my two factors are x minus 4 and x plus 2. So that gets us to where we started the last time. So we're just going to set each of these little baby equations equal to 0. And so this one's going to be a positive 4 because I just added 4 to both sides. And this one's going to be a negative 2. I just subtracted 2 from each side. So that's my answer. So I'll write the steps on this one. There's a step that we didn't have to do on this one, but let's go ahead and write the steps. We did almost all the steps on this one. Step 1 is going to be get it in standard form, if it's not. This one was not in standard form, so we did this step this time. We had to move that 2x to the other side. So we want to get it ax squared plus bx plus c equals 0. That's what it's got to look like for us to start solving by factoring. After we've got it in standard form, this one we didn't have to do this time. We're going to factor out any GCF we can. This one didn't have any greatest common factor, so we didn't have to do that. We just leave that till the end if we do have one. Next step that we're going to do is actually do all the work to factor. And I'm just going to put, do the whole box thing. Step 4, we're going to write the pair of factors equal to 0, right? So it's going to be x it's going to be something times something equals 0, or it's got binomials in there, or sometimes they're not going to be two binomials, but usually it's going to be two binomials. We'll see some examples where it's not. Then we're going to solve, set each factor equal to 0, and solve. Solve each little equation. And you're going to start to see how those answers work. I'm not concerned if you don't show me the work on that last step after you've done a few. Okay, so that's all the steps. So the only step we haven't seen is factoring out a GCF, and we'll just make sure we do some kind of different examples too. 6x squared minus 24 equals 0. So it's not a trinomial. Again, the instructions on all these are going to be solve by factoring. You might have another way that you might think about solving. It's in standard form, so we're going to factor out a GCF. Again, these are my notes, so I don't want to mess with my original. I factored out a 6. 6 times x squared gave me 6x squared. 6 times negative 4 gave me negative 24. So this is one of those special cases. It's x plus 2, x minus 2. It was a difference of squares. And so you've seen me do a couple. I would set each of these little factors equal to 0. So my answers are negative 2 and 2. Now when we were asked to factor, we had to bring that 6 down. If I'm just solving, that 6 is not part of the answer. This is a second degree equation, meaning it's got an exponent of 2. So it's not going to have more than 2 answers. It might have less. It might only have 1. But it's not going to have more. That 6 is 6. That 6 cannot be one of the factors that gets us to 0. The two factors that could get us to 0 are -2 and 2. Let's look at another binomial. 4x squared minus 8x equals 0. So it's not a perfect squared binomial. I can factor something out. This time what I can factor out happens to have an x in it. I can pull a 4x out, and 4x times x gave me my 4x squared. 4x times -2, I guess 2's are in my head today, 2's and 4's. 2 times 4 gave me my 8 there. So now, this time, the thing that I factored out has an x in it. So that is going to give us one of our solutions. We're going to set that equal to 0 as well as setting this equal to 0. So this one's going to be 2. How do we do this other one? Well, if I divide both sides by 4, remember, it's not undefined. We can do 0 divided by a number. So our other answer is 0. So those are our two answers. And keep in mind, what we're heading towards is also graphing these. What we're saying when we have these equal to 0, we're really finding the x-intercepts. Picture a y. This is not part of the problem. This is the little preview. If that was a y, we substituted a 0 for y. And what we're finding when we do this is we're finding x-intercepts. And so we have a parabola. We know that we have an x-intercept of 0 and an x-intercept of 2. And we know it opens up. We know it's skinny, so it would end up looking something like that. Again, ugly, ugly rough sketch. This one, x-intercept of -2, x-intercept of +2. Very, very skinny because it's got a 6. Very, very, very skinny. It probably goes way further down than that. But again, what we're doing when we're finding these x's, when we're solving, is we're finding x-intercepts, because you've got to think we're replacing the y with a 0. We'll see those graphs soon enough. All right. So let's do one where we've got to do all the steps. We got 12x squared minus 16x equals 60. So that's our problem. First thing we have to do is get it in standard form. So we're going to subtract 60 from both sides. 12x squared minus 16x minus 60 equals 0, written in descending order. Those are mighty big numbers. Looks like I can factor a 4 out. If I factor a 4 out, I have 3x squared minus 4x minus 15 equals 0. That's much easier to deal with. Now I'm dealing with 3 and -4, whoops, and -15. So I'm looking for things that multiply and give me -45 and add to -4. So we have 1 and 45, 3 and 15, 5 and 9, and that's what it's going to be. So build our box. First term comes down to the first box. Again, we don't go back to the 12. We start with the thing after the factoring. So put our 3x squared, our -15, bring over our positive 5x and our -9x, and these guys share just an x, these guys share a -3, these guys share a 3x, these guys share a 5. So I've got, let me go where I've got more room. I've got x minus 3 and 3x plus 5. So from here down is where it's the only thing to do. I've got x minus 3 equals 0, so x is 3, and I've got 3x plus 5 equals 0. So I've got a couple more steps to do on this one. When I have something other than just one coefficient on x, I'm going to have to do some division. I'm going to end up with a fraction, -5/3. So those are our two answers. 3x squared plus 6x plus 3 equals 0. Everything's positive, don't have to worry about signs, that's nice. But I can pull out a greatest common factor. X squared plus 2x plus 1. I could start to write A and B and C, but I recognize this as one of those special patterns. That's a perfect square, that's a perfect square. So it's going to be x plus 1, x plus 1. It's not the difference of squares. Bring down that 3. But now notice, when this thing is repeated, I said there's never going to be more than 2 solutions. There's only one solution to this problem. It's just -1. And because I can't resist, let's look at what would this look like graphed. Well, the x-intercept There's only one of them. That means the x-intercept is the vertex. It's got that 3 in front, so it's really narrow. We know that the c ends up being our y-intercept, and so it's going to be this very skinny parabola right about there. Okay? Ugly, but just giving you the little preview looking ahead.